Hello folks, my presentation is about correlation and regression. Our goals are to learn how to create and interpret a scatter plot, what a regression line is, when and how to compute the Pearson R, how to perform significant testing of the Pearson R. Correlation is used to understand the relationship between variables. Let me ask you some questions. Do you think that there may be a relationship between rising temperature and selling ice cream? What about rising temperature and hat sales? What about rising temperature and sandwich sales? What about rising temperature and coffee sales? And at last, what about rising temperature and coat sales? For example, we may want to say whether there is a clear relationship between increasing the temperature and the number of ice creams that are sold. Using a scatter diagram, we can plot selling ice cream score in our sample against the amount of temperature. We can see there is a pattern. Now, can we say how much more selling of the ice cream can be expected to be when the temperature goes up? According to its scatter plot, it looks like the relationship is positive. As there is more heat, there tend to be more sales of ice cream. As we draw a line in the middle of these dots, we can show this relationship and its type that is positive. Now let's see the relationship in increasing the temperature and selling hats. As it shows, there is a relationship between these two variables, but it's not as strong as selling ice cream. Now let's see this relationship in increasing temperature and selling sandwiches. As its scatter plot shows, there is no relationship between these two items. And what about increasing the temperature and selling coffee? Looks different. There is something new. When the temperature goes up, selling coffee goes down. It seems that there is a negative relationship between these two variables. And at last, relationship between increasing the temperature and selling coats. Again, according to its scatter plot, we can understand that there is a negative relationship between these two variables, and it is stronger than the previous one. We can also, to some extent, tell from a scatter plot how strong the linear relationship is by how closely the points sit together in the linear pattern. For example, in the left-hand diagram, where points are closely following a linear pattern, we say the correlation is very strong, whereas the data on the right-hand diagram is loosely spread in the linear pattern. And we would say that this is weak or intermediate strength linear correlation. This is good, but we want something a little more precise to measure our relationship. And this is where the correlation coefficient comes in. This idea was developed by an English mathematician called Carl Pearson, and hence is known as Pearson's correlation coefficient, and it is denoted by R, subscript XY, or simply R. Now let's go back and examine the 5 graphs we draw side by side and compare their correlations. About ice cream, when the temperature goes up, the amount of sales goes up strongly, nearly a straight one. So we call it strong positive correlation or perfect positive correlation. About hats, when the temperature goes up, the amount of sale goes up, but not too strong. So we call it intermediate positive correlation. About sandwich, when the temperature goes up, there is no change in the amount of sandwich sales, so there is no correlation. About coffee, when the temperature goes up, the amount of sales goes down, but not too strong. So we call it intermediate negative correlation. And about coats, when the temperature goes up, the amount of sales goes down strongly. So we call it perfect negative correlation. What we're going to do now is to assign these numbers. But what is the correlation coefficient going to be? So what happens is that the information is set to a number line that goes from -1 to +1. So you can imagine that if a scatter plot has no correlation, that would be a 0. So this is the R value we mentioned. If the correlation is 1, that's gonna be a perfect, strong, positive correlation. And if the R value is -1, that's gonna be a perfect, strong correlation, but it's negative. In that, the scatter plot is decreasing. And then we have all of these numbers in between. So your correlation coefficient is gonna be from 0 to 1 if the scatter plot has at all a positive trend, and then it will be from 0 to -1 if the scatter plot has at all a hit of being negative correlation. So we will say this is right about 0.5 and this would be -0.5. So that's what the correlation coefficient is. So if we compare different correlation coefficients, we need to keep in mind that it's the strength that we are looking at and not the type or direction. So if we had an R value, so let's say R is -0.885, that correlation coefficient would be greater than 0.62. So even though this one is negative, that just tells you that it's a decreasing scatter plot, but 0.85 is stronger than 0.62. So remember that the negative tells you the direction of the scatter plot, and the number from 0 to 1 or 0 to -1 tells you the strength of the correlation. So the correlation coefficient, which is your R value, tells you the strength, but it also tells you the type, is it positive or negative. We also summarize the relationship by drawing a line through the scatter plot. This line is called regression line. The regression line is the straight line that summarizes a relationship by passing through the center of the scatter plot. This is although not all data points are on the line, the distance that some are above the line equals the distance that others are below it. So that on average, the regression line passes through the center of the scatter plot. Now let's see what's the formula for calculating correlation coefficient R. Don't worry, contrary to its scary appearance, it is very easy to calculate. Let's have a challenge with this formula in an example. For example, we asked 10 people the number of times they visited a doctor in the last year and the number of glasses of orange juice they drink daily. To describe the linear relationship between juice drinking and doctor visits, we compute R. Calculating the correlation coefficient can be done in 3 steps. Step 1 is to compute these items and then put them in formula with the help of additional columns in the table. Step 2 is to compute the denominator. Step 3 is to compute the denominator and then divide. So, according to our data, we can complete all items in step 1 and complete the table. Our correlation coefficient between orange juice drinks and doctor visits is negative 0.95. Our negative 0.95 indicates an extremely strong negative relationship. Each amount of orange juice is associated with a very small range of doctor visits. And as juice score increase, doctor visits consistently decrease. Therefore, we envision a very narrow scatter plot that slants downward. Thank you for watching.